In this lesson, you are going to learn about absolute value functions and absolute value transformation. We're going to begin by looking at the definitions of absolute value and then also the graph of the absolute value parents function. Now, absolute value parents function is y equals to absolute value of x. Okay, so this is the most basic function in an absolute value function family. Okay, it doesn't get any easier than this. Now, absolute value, okay, when you're working with absolute value, you have to think about the distance between the values of x, so whatever x is, and 0. So you're talking about distance. And distance can never be negative. So when you're taking an absolute value of a number, you're always going to end up with a positive number. Okay, because you're talking about distance. The distance from 0 to the values of x. And it will be denoted by this symbol right here. Okay, the two lines coming down, it's an absolute value symbol. Okay, so if you're taking an absolute value of -4, so the distance from 0 to -4 would be 4. Okay, you see how it comes out to a positive number? Okay, so when you're working with absolute value, okay, you're always going to end up with a positive number. Okay, so we're going to get into graph of absolute value parents function. So here again, y equals absolute value of x. So we're going to graph this by making a 2-column table. Pick the values for x. Okay, and then plug it in to come up with y. And then we're going to be able to come up with points, or ordered pairs. Okay, and then we can use them to plot and come up with the graph of an absolute value parents function. Here's a 2-column table. Okay, so we're going to work with these numbers for x. So we're going to work with -2, -1, 0, 1, and 2, okay? Here, when I plug in -2 into x, I'm taking absolute value of -2. Okay, what's the absolute value of -2? Well, that's going to be 2, because the distance from 0 to -2 is 2. And then absolute value of -1 is 1. Absolute value of 0 is 0. And then absolute value of 1 is 1. And then absolute value of 2 is 2. We have these ordered pairs, okay, that we can use to plot and come up with the graph of the absolute value parents function. Okay, so here's a coordinate graph. Okay, you have the x-axis here, and then you have the y-axis here, and here's your origin at the point 0, 0. All right, so we're going to plot -2, 2, so that means we got to go 2 left and then up 2. So -2, 2 is right here. And then -1, 1 is right here. And then 0, 0 is at the origin. And then 1, 1 is 1 right, 1 up. And then 2, 2 is 2 to the right, and then 2 up. Okay, and then we connect those into a graph of an absolute value. Okay, so that's what the graph of an absolute value looks like. Okay, it's a graph of a V shape. So this is the graph of an absolute value parents function. Okay, so next we're going to talk about the domain of the graph absolute value parents function. Well, domain is your x. You can plug any number in for x and be able to take the absolute value of it. That means your domain is any numbers you can come up with. Okay, so how do we write it out? We can say it's all real numbers, or we can say it goes from -infinity up to infinity. Okay, so that's in all real numbers. So this is an interval notation, okay, for all real numbers. Now your range okay, is the y. The range is the y. If you look at the y for the absolute value function of this, now it starts at 0. See it? Okay, it doesn't go, the graph does not go below 0. So the graph of this absolute value is all the numbers that are above of 0. So your range, I mean, it's not going to come out to negative, because when you take absolute value of a negative number, okay, negative 2 here, for example, you're going to get a positive number. So your range is going to start at 0. Okay, the bracket means it's including the number 0. If you put 0 in for x, your absolute value for 0 is 0. But it just cannot be negative, okay? It cannot go below 0. And then it's all the numbers that are above 0. So it goes up to infinity. So there's your interval notation. So it's all real numbers that are greater than or equals to 0. And then the last thing here is your vertex. Well, the vertex of this parent function is right here. So what is the location of that point? The location of that point is going to be at 0, 0. So the vertex of the absolute value parent function is at the point 0, 0. Right here, I'm going to show you how to work with function notation connections with absolute value function. So use the given f of x. Okay, that's f of x here is in function notation to calculate the g of x. So we have to use f of x to come up with g of x. Okay, given that f of x is 3 times absolute value of x plus 4 take away 2. So here you're given f of x. You have to use it to come up with g of x. So let's see what g of x is. So here g of x is f of x take away 6 plus 10. So we have to come up with f of x take away 6 plus 10. The x minus 6 is the x of the f of x. So what that means is you got to take that x minus 6 and you're going to plug it into the x of f of x. So it's going to look like this. Okay, so g of x is 3, and then the absolute value. Okay, and then you're going to put in x minus 6. So replace x minus 6 with this x right here. And then bring over the plus 4, and then bring over the minus 2. Then don't forget the plus 10. Okay, see this 10 right here? So all we did was plug in x minus 6 into x to come up with g of x, right? So g of x is f of x minus 6 plus 10. Okay, so here we have 3 absolute value of x take away 2, right? Negative 6 plus 4 is 2. And then here, negative 2 plus 10 is positive 8. Okay, so this is what g of x is. Okay, now I'm going to show you absolute value transformation. Okay, so here's an absolute value function, absolute value equation in standard form. Y equals to a times absolute value of x take away h plus k. I'm going to show you the effects of a, h, and then k. Okay, what a, h, and k are doing to the parent function. Okay, and that's your transformation. Okay, so this is what a is doing to the parent function. Now, if a is bigger than 1, okay, the graph is going to stretch. So the graph is steeper. Now, if a is between 0 and 1, so if a is 1/2 for an example, okay, a half is between 0 and 1. So graph it shrunk, looks less steep. Okay, now if A is negative, okay, let's say you have a negative sign in front of A, okay, graph is reflected and then it opens down. So the V shape, when you graph absolute value, you're going to get a V shape. Okay, so the V is going to open down. That's the effects of A. That's what A is doing to the parents function. Down here, this is the absolute value equation in standard form. So H right here, guys, if H is positive, the graph is translated right H units. So let's say you have x minus 3, okay, and then 3 is a positive number. H is 3. So you're going to go to the right 3 units. Okay, so you move everything. You move the parents function to the right 3 units. Now, if H is negative, okay, let's say you have x minus and then negative 3. Okay, you see how it's a negative number? Negative 3. So then you have x plus 3, right, inside the absolute value. So if this is a negative number, just like we have here, it's going to translate to the left H units. So in this case, it'll go 3 units to the left. So that's what H is doing to the parents function. Now K, okay, so your K is going to go up or down depending on what K is. So if K is positive, the graph is translated up K units. So if this was a plus 3, then it go up 3 units. If H is negative, graph is translated down K units. If it's minus 3, okay, if you get minus 3 here, then it's going to go down 3 units. Last thing I'm going to talk about is the vertex. Okay, so to get the vertex of the absolute value function, okay, so the x-coordinate of the vertex is what H is. Okay, so remember, it's just this number right here. So if it's minus 3, your H is 3, so 3 goes here. Now it's plus 3. If that was plus 3, okay, then H is negative 3, because the minus is a part of the standard form. And then the K, the y-coordinate, is just what K is. So that's how you come up with the vertex of the absolute value function. In this example, I'm going to show you how to come up with the absolute value function that has these transformation. So let's take a look at the first one. The transformation for this one has been translated right 7. So you go into the right 7 from the parents function. Okay, so here's the parents function. It's y equals to absolute value of x. The standard form of an absolute value function is y equals to a absolute value of x, take away h, and then plus k. Okay, so that's the standard form. So now if you look at this, the a for this one, the a for the parents function is 1. So your a is 1. The h is 0. So the h of the parents function is 0. And then the k is also 0. So you have y is 1, right? There's a 1 there. You don't need to put the 1 there if you don't want to. The parents function. And then x take away h. So the h of the parents function is 0. And then the k is 0. This right here is like the parents function. Okay, because the h is 0 and the k is 0 for this one right here, up here. This transformation is translated right 7, right? So you go into the right 7. So the h is your left or right. Okay, so we're going to add 7 to this. And that's the only thing that's going to change Okay, so here's the new function. Y is, okay, absolute value of x minus 7, okay, because you're going 7 units to the right, so that's positive 7, and then plus 0, and we don't have to put the 0 there. Okay, so this is the equation that we're looking for. Okay, and then we can write this in function notation. Okay, so the function notation would be f of x, okay, equals to absolute value of x take away 7. Okay, and that's what you're looking for. All right, let's take a look at the next one. So this one has been translated down 10 from the parents function. Okay, so f of x is, okay, so here is so you got absolute value, x take away 0, and then plus 0. Okay, so this one we're going down 10. So that means you got a minus 10 to this one, because that's your up or down, right? So the new function after the transformation is going to be f of x is absolute value of x, okay, we're not going to put the 0 there, okay, minus, because you minus 10 to the 0, okay, you minus 10 over here, so it'll be negative 10 here. So this right here, okay, it's the parents function minus 10. So you're going down 10 units from the parents function. All right, let's take a look at the next one. Now this one has a vertex. So the vertex is at 4, 5. So the h is the x-coordinate of the vertex, and the k is the y-coordinate of the vertex. How do we write an absolute value function that has a vertex of 4, 5? So here you go. F of x, absolute value of x, take away, okay, you're always going to take away here because the standard form. So the h, here's your h, okay, so that's your h. So that'll be minus 4. And then here's your k, so that's your k, plus 5 because it's positive 5. Okay, so this right here has a vertex at 4, 5. All right, let's look at the next one. Say this one has a vertex at negative 2, negative 6. So it's the same thing. So you got f of x. So this right here, okay, is going to be your h. Okay, and then the negative 6 is going to be your k. So you got absolute value. Now you got to go x minus negative 2. Okay, we plug in the h. Because it's negative 6, it's going to be minus 6. And we just have to simplify this. So f of x is absolute value of x. Now here you got negative times negative. So you got a negative times a negative. So negative 1, okay, times negative 2 makes it plus 2. So that comes out to plus 2. And then you bring down the minus 6. Okay, so this absolute value function has a vertex at negative 2, negative 6. Okay, so now here we're going to do the opposite of the previous example. Previous example gave us the description of the transformation, and we have to come up with the equations. So this example here is the other way around, where you're given an equation and you have to describe the transformation compared to the parents function. Let's take a look at the first one. So here you're given g of x is negative 3 times absolute value of x plus 1. Okay, here's your a. So your a is going to stretch or shrunk based on this number right here. And then you have the negative in front, so that makes it a reflection. So the negative is reflected across the x-axis. And because your a is bigger than 1, it's going to stretch by a factor of 3. Okay, so if it's bigger than 1, it's stretched by that factor. Okay, so that's what's going on here. And then here's your h. Okay, so think of this as minus negative 1, right? Because it's plus 1. See the plus 1 right here? Because your standard form, okay, the equation for the standard form has a minus. Okay, so therefore the 1 has to be a negative 1. So that means it's going to go to the left 1 unit. So the h is your left, right. And then since there's no k, it's like plus 0, so it doesn't go up or down. So we say g of x is reflected. So this is from the parents function, right? From the parents function, g of x is reflected over the x-axis. What else? Okay, remember we talk about here, stretch. So it's stretch. So g of x from the parents function, g of x stretch by 3, a factor of 3, right? Because of the 3 bigger than 1. And then the last one, and it goes to the left. Okay, how many unit? Well, just 1 unit, okay? All right, so that's the transformation based on the given equation. Okay, let's go on to the next one. Okay, so the next one is g of x is 1 over 4x minus 7. Okay, you have to describe this transformation, okay, compared to the parents function. Again, look at the a. You got a is changing. See it? So a is not 1. It's 1 over 4. And then your h is 0. There is no h because it's minus 0. And then this is your k, right? So this one is up or down. From the parents function, g of x, okay, so this 1 over 4 is between 0 and 1. Okay, so because it's in between 0 and 1, g of x is, okay, this one's going to shrunk by 1/4. What about this k? Minus 7. So we would say n, right, it goes down 7 units. Okay, and that's how you compare it. Let's go on to the next one. So here's g of x. Okay, this one has everything. So you got the a, so that's your a. It's bigger than 1. Okay, and here's your h. Just the 3 is your h. Okay, and then this is your k. So we have to compare all of that to the parents function. So from the parents function, right, g of x is, so this is bigger than 1. Your a is bigger than 1, so we say stretch, right, by 2, factors of 2, and so that's going to go to the right, right, because it's positive 3. So right 3, and then and. Okay, what is this going to do to the parents function? Well, it's going to take the parents function 5 units up because it's plus 5. Okay, so you can go up 5. So that's it. So stretch by factors of 2 to the right 3 units and then up 5 units. Okay, let's take a look at one more. So g of x here is negative 1/2. Okay, so this one has the negative 2. So So from the parents function, you got the negative, you got the 1/2, okay, you have the h, and then you got the k. Okay, you have all of them. Okay, so from the parents function, g of x is reflected across the x-axis because of that negative, right? Okay, what else? Well, 1/2. So 1/2, your a is 1/2. So 1/2 is between 0 and 1. Okay, then you go shrunk by a factor of 1/2. And then h, see how that's a plus? So think of it as minus -2, right? So your h is -2. So you go left. Okay, how many units? 2 units. And then the last one, okay, it's -4. You just say down 4 units. Okay, so from the parents function, this is what it's doing with all those variables, a, h, and k. Okay, so now we're going to get into graphing absolute value function. All right, so graphing g of x is -2 times absolute value of x plus 3. All right, so first thing we need to do is come up with the vertex. So the vertex is hk, right? Okay, so your vertex, the x-coordinate of the vertex is your h. So look at your h is 0 because it's -0 here. If you compare this to the standard form, because x minus h, right, inside. So it's 0, and then the y-coordinate of the vertex is k, so that would be 3. Okay, so that is going to be your vertex. So that's the first thing you need to do. And then after that, you're going to make a table because you want to come up with ordered pairs with points that you can use to get the graph. Okay, so here's your 2-column table. Okay, make a table, the x column, and then the y. Yeah, we're going to use 5 points. All right, so that means your vertex is going to be in the middle, right? The 0 is going to be in the middle. Okay, and then we're going to pick -1, -2. So 2 numbers to the left of 0, and then 2 numbers to the right of 0. Okay, now we know that when x is 0, y is 3, because that's from the vertex. Okay, so now we plug -1 in for x. So -1, absolute value of -1 is 1. 1 times -2 is -2, plus 3 is 1. Then we're going to plug in -2 for x, so -2 here. Absolute value of -2 is 2. 2 times -2 is -4. And then -4 plus 3 is -1. Okay, and then plug in 1. So when you plug in 1, you get 1. And then plug in 2. When you plug in 2, you get -1. Okay, so we have those. Okay, we're going to plot those points and then come up with the graph of this. All right, so let's bring in a coordinate plane. Okay, so here's a coordinate plane. So we're going to plot these points. -2, -1. So 2 to the left and then down 1. So here's -2, -1. And then -1, 1. So we're over here. And then your vertex is going to be 0, 3. So 0, 3 is going to be up here. Okay, so that's your vertex, right? And then 1, 1 is over here. And then 2, -1 is down here. Okay, so with those, we're going to make a V shape a graph of a V shape because that's the graph of an absolute value. Okay, now it doesn't look perfect because of the intervals are not. Okay, so the intervals, as you can see, some are bigger than the other. So this is the best we can do. Okay, so that's the graph of this right here. So now notice this right here, the negative is reflection. See how it's reflection across the x-axis? And it's a stretch by a factor of 2. You can tell that the graph is stretching. And then it goes up 3, right? The vertex from the parents function, 0, 0, and then it goes up 3. Okay, so here's another one. Graphing f of x is 3 times absolute value of x plus 5, and then take away 7. Okay, so first thing we need to do is come up with the vertex. So think of this right here. See this plus right here? So it should be minus negative 5, like that. See it? So you can see what the h is. Okay, because standard form has x minus a number h. What is your vertex? Well, your vertex is hk. So your h is going to be negative 5. See it? Here's your h. And then your k is going to be negative 7. Okay, so that is going to be your vertex. So we're going to use this, okay, to make a table. Okay, so let's take a look at the table in the coordinate graph. Okay, so the left column is going to be your x. And then the right column is your f of x, your y. So we're going to put negative 5 in the middle because that's the vertex, right? And then we're going to use negative 6, negative 7. And then to the right of negative 5, we use negative 4 and then negative 3. Okay, so we're going to plug those numbers in. Okay, and then come up with the f of x. All right, we know the vertex. If we plug negative 5 in, we know we get negative 7, right? Because it's right here. Okay, so if we plug in negative 6. So negative 6 here, guys. Negative 6 plus 5 is negative 1. Absolute value of negative 1 is 1. 1 times 3 is 3. 3 take away 7 is negative 4. And then we plug in negative 7 in here. Negative 7 plus 5 is negative 2. Absolute value of negative 2 is 2. 2 times 3 is 6. 6 take away 7 is negative 1. And then the same thing on this side, negative 4, and then negative 1. All right, so now we're going to plot those points. So negative 7, negative 7, negative 1 is right here. Okay, negative 6, negative 4, 1, 1, 1, 2, 3, 4. So we're all the way here. And then negative 5, negative 7, negative 5, and all the way down 7 here, negative 5. So this is going to be your vertex right here. And then negative 4, so it's going back up. So negative 4, negative 4. And then negative 3, negative 1. So we're right over here. Okay, so we're going to use those to make the V shape. Going like that. And like that. Okay, so it's not perfect. Okay, so that is the graph of this right here. Okay, as you can see, your vertex is at negative 5, negative 7. So it's down here. That's your vertex. Okay, and then you got these points. All right, so that's how you graph an absolute value function. I hope these examples are helping your understanding of the transformation. Please help share and subscribe down below. And I thank you so much and see you guys next time. Thank you.